Today we will see how the doubly reinforcement is to be designed. Before that, we have to draw this table. In this table, different slab types, LX that means shorter span, LY longer span, WU that means load which has came with respect to particular slabs. After that, one column is given by formula for short side and on long side. By using these two formula, we can calculate these values. Let's see. Here, beam number 48 is given as with respect to values like FCK, FY, cover and effective length. This effective length has been taken from a beam length, but this effective length, for example, if my wall thickness is 0.3 meter, then length of a beam will be as per given design. Effective length will be calculated as respective length plus wall thickness. Beam width is to be assumed here, that is 230 mm. Beam depth is 380 mm. Effective depth will be calculated as 380, that means overall depth minus 20, it is cover 360 mm. Let's see about load calculation. First of all, self weight, it is calculated as 25 into B into capital D. Here B is equal to 0.23 meter, that means beam width. Here capital D is overall depth. After that, brick masonry load is calculated here, and load on slab, this value has been taken from a table 16.25. For example, if this beam number 48 lie in slab number 5, in slab number 5 we have to check design, we have to check our drawing in such a way, if my beam number 48 lie on longer side, that means I have to check this value here 16.25. If suppose my beam lie with respect to shorter side, then I should take this value, that means 11.88 kilonewton. So I have taken this 16.25 kilonewton because my beam lie on longer side. After that, factored load will be total load will be calculated as addition of these three loads weights, and after that multiplying by partial safety factor, multiplying by partial safety factor, we will get factored load. Then bending moment calculation. In bending moment calculation, mu is equal to wu, that means factored load, into Lx effective whole square divided by 8. After calculating this, we will go for the mu limit. Mu limit will be calculated as 0.138 into FCK into B into D square. After that, if my mu is greater than mu limit, then we have to go for doubly reinforcement beam. Area of steel in compression side will be calculated as given formula, but before that we have to go for a check. D dash by D effective will be calculated first, and after that here from IS 456 2000 clause number 2.3.2 page number 13, from that table we have to calculate respective FSC values. After getting FSC value, we have to use this formula. ASC is equal to mu minus mu limit divided by FSC in bracket D minus D dash. After putting all these values, we will get ASC. Then taking a diameter as 12 mm, we have to calculate small ASC. After calculating small ASC, we will calculate number of bars required. That means capital ASC divided by small ASC. After getting number of bars, we have to go for tension steel calculation. For tension steel, we have to use a formula as AST is equal to AST1 plus AST2. For AST1, we know that formula 0.5 FCK upon FY in bracket 1 minus under root 1 minus 4.6. Here MU limit is taken out, divided by FCK B into D effective whole square into B into D effective. After calculating AST1, we have to go for AST2 calculation. Here AST is equal to ASC into FSC divided by 0.87 FY. After calculating AST2, we have to calculate AST. Using 16 mm diameter, we have to calculate AST. The number of bars will be calculated as capital AST by small AST. After getting number of bars, we have to check for shear. Vu is equal to WU into L divided by 2. Here we have calculated this WU before this. I will show you 45.73. Here factored load is calculated as 45.73. That means WU. Putting this value here, we will calculate Vu, that means shear force, factored shear force. After that, shear carried by stirrups will be calculated as VUS is equal to VU minus tau VU minus VUC. We will easily get VUS. Here, VUC will be calculated as tau C into B into D. Here, ASV is equal to 2 into pi by 4 into 8 square. With respect to that, this two-legged stirrups is here. Two-legged stirrup is used, and 8 mm diameter is to be taken for reinforcement. Then VUS will be calculated as this formula. After that, but we have to find the spacing, so that spacing will be calculated. SV will be calculated as 0.87 FY ASV D divided by VUS. We will easily get spacing here. This is first criteria. Second criteria, 0.75 times D. Here D is D effective. And third, SV is equal to 300 mm. Choosing minimum among them, we will take this value.